Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is permutation and combination theory. Permutation and combinations is considered by some students as one of the toughest topics primarily because each problem that will come under this topic will be different. It would require the applications of one's reasoning skills and it does not fit into a small framework of generalizations and formula like the other topics that we generally discuss in mathematics. Though this topic might seem cumbersome at first, if analyzed carefully, it is just an extension of various number system principles or counting principle. So let's first understand the fundamental principles of counting, as there are too many concepts with just some minor differences. Every concept can be discussed along with some illustration of that concept. So we can learn not only the concept but also its application. Here we go. Let us start with fundamental principle of counting. This can be done in two ways. First way is by multiplication. Second way is by using addition. Let us see multiplication first. If there are two jobs such that one of them can be completed in p ways and after its completion in any one of these p ways, then the second job can be completed in q different ways. Then the two jobs in succession can be completed in p times q ways. Hope you're clear with this definition of multiplication process. Okay, I'll give you one illustration so that you can understand the concept clearly and its application. Here is an example. In a class, there are 15 boys and 10 girls. The teacher wants to select one boy and one girl so as to represent the class in a function. In how many ways can the teacher make the selection? Okay, so here the teacher has to perform two jobs here. Selecting a boy among 15 boys and a girl among 10 girls. So the first task, selecting a boy among 15 boys, can be done in 15 different ways. And the second task, selecting a girl among 10 girls, can be done in 10 different ways. Am I right? So by the fundamental principle of multiplication, we just multiply the number of ways for each of the tasks. Am I right? So 15 times 10, that would be equal to 150. This is the first task, second task, and number of ways to complete the task 1, number of ways to complete task 2. And by multiplication fundamental principle of counting, just multiply. By the fundamental principle of multiplication, the total number of ways is 150. Hope you're clear with this concept, multiplication. Okay, now let us discuss about fundamental principle of addition. Let us first see what is meant by addition fundamental principle. If there are two jobs such that they can be accomplished independently in two different ways, for example A and B. I'm using two variables A and B here. If there are two jobs that can be accomplished independently in A and B ways respectively, then either of the two jobs can be accomplished in A plus B ways. That is called fundamental principle of addition. Let us see one illustration and see how it is going to be applied. Here is the example. In a class, there are 15 boys and 10 girls. The teacher wants to select a boy or a girl so as to represent the class in a function. In how many ways can the teacher make the selection? Do you understand the difference between previous one and this one? In the previous problem, we wanted to select a boy and a girl, but here we are going to select a boy or a girl. So here the teacher has to perform either of the two jobs. Either she has to select a boy among 15 boys or she has to select a girl among 10 girls. So these are the two tasks. The first task can be accomplished in 15 ways and the second task can be accomplished in 10 ways. By the fundamental principle of addition, either of the two jobs can be accomplished in 15 plus 10. You just have to add the number of ways. So totally 25 ways. The teacher can make the selection of either a boy or a girl in total 25 ways. These principles that we just discussed, multiplication and addition in fundamental principle of counting, can be extended to any finite number of jobs, not just for two jobs. Hope you're clear with this concept. The next theory we are going to discuss in this video is permutation. Let us discuss the formula and the examples on permutation. Let me tell you about permutation. Each of the arrangements which can be made by taking some or all of the numbers of the things is called permutation. I'll give you one example. Permutation of the three letters XYZ. taking all at a time, it is just the arrangement of each of the letters given. We are taking all at the time. This can also be done by taking some at a time. Let us take two letters. The permutations of the letters, three letters XYZ taken two at a time would be. Hope you're clear with this definition. Okay, now let me give you the formula. Permutation of n distinct objects taken r at a time is denoted by npr, and the formula is n factorial divided by n minus r factorial. This can also be denoted by, you'd be seeing this notation in your calculator, scientific calculator. Here the n and r we are using here are positive integers, and r lies between. There is some restriction for n and r. I'll give you that too. Hope you're clear with the formula. Okay, now let me show how I'm going to show you some examples and you can understand the application of permutation and its formula. Here is an example. In how many ways can three non-identical rings be worn in five fingers? Such questions in which things are to be distributed among someone or something. Please note that the things to be distributed always comes in the power. So total ways of distributing the rings amongst the five fingers would be 5 raised to 3. So 5 raised to 3 is equal to 125. The total ways thus come out to be 125. Or we can say that there are 5 ways for the first ring, and 5 ways for the second ring, and 5 ways for the third ring. Am I right? So 5 times 5 times 5. Fundamental theory of multiplication. That will also give you 125 cases. In this example, you saw how to find the possibilities. Here is another example. How many 4-letter words with or without meaning can be formed using the letters of the word fatherly, using each of the letter exactly once, having essentially F as one of the letters? Okay. We are going to create 4-letter words. F can either be the first letter, or F can be a second letter, F can be a third letter, or F can be the last letter. So let's find the permutation for this one. So totally there are 8 letters in this word, and we are going to pick 4 letters. So F was the first one, so 8 minus 1 is 7, and we have already picked F, so 4 minus 1, so 7p3. Same for all the other 3 tasks. You can just apply the formula of permutation and find the value for each of the tasks, and for total number of words you have to add all the ways, the possible answer. Okay, let us generalize the formula. Permutation of n distinct objects taken r at a time, where a particular object is never taken as n minus 1p r. Here one particular object out of n given object is never taken. So we have to find the number of ways in which r places can be filled in with n minus 1 distinct objects. Clearly the number of arrangement would be n minus 1 pr, as we did in the previous problem. Permutation of n different objects taking r at a time, in which 2 specified objects always occurs together is 2 factorial and r minus 1. So here if we leave out 2 specified objects, then the number of permutations of the remaining n minus 2 objects taking r minus 2 at a time would be n minus 2p r minus 2. Now consider 2 specified objects temporarily as a single object, and then add to each of this n minus 2p r minus 2 permutations, which can be done in r minus 1 ways. Thus the number of permutations become r minus 1 times n minus 2p r minus 2. But the 2 specified things can be put together in 2 factorial ways. Hence the required number of permutations is. These concepts may look somewhat vague, but if you start solving the problem you can understand all these. What we have to do if you are asked to find the permutation of objects that not all distinct. Till now we have been discussing permutations of distinct objects, taking some or all at a time. Now we will discuss the permutations of a given number of objects when not all the objects are different. The number of mutually distinguishable permutations of n things taken all at a time, of which p are of one kind and q are of second kind, such that p plus q is n factorial divided by p factorial times q factorial. This is the permutation formula you have to use when you are asked to find the permutation of objects when not all distinct. Okay, so what would be the permutation when the objects can repeat? If the repetition allowed, you have to use this formula. The number of permutations of n different things take an r at a time, when each may be repeated any number of times in each arrangement, is n raised to r. This concept can be explained by comparing this permutation with the number of ways in which r places can be filled by n different things, when each thing can be repeated r times. Here next theory is circular permutation. Permutation of n distinct objects along a circle can be done in n minus 1 factorial ways. Circular arrangement means it can either be clockwise or anti-clockwise. So permutation along a circle, clockwise and anti-clockwise arrangements are considered alike. So these are the information you should know about the permutation and combination. This is the first part. We can continue combinations in second part. In case if you have any query regarding the theory that we have discussed in this video, please let me know.